Hello and welcome to this Trinity video. This video demonstrates how the module simulation welding can be applied and operated. The goal of this video is to showcase how this system works. We will demonstrate how to program the robot with visual components to perform welding. The idea is to use Visual Component, which is a relatively simple program to program the robot movements. We will first showcase the welding of a line, so a linear movement with the robot. Afterwards, we will showcase a more complex movement using the path function, which is built into Visual Component. This allows us to automatically generate path by the shape of a CAD model. First, you open Visual Components and then load your file of your digital twin of your welding system. Afterwards, you press the program function. This allows us to program our robot. If you press on the robot, on the right-hand side, you will see the A1 to A6, which is the joints of the robot, which can be moved, as well as E1 and E2, which relate to the rotary table, which can also be jogged and moved. To program the robot and add points, you use the buttons which are highlighted in the red square. Here there are three options for adding a movement. You can either choose a point-to-point motion statement, which moves the robot from point A to point B as fast as possible. You also have the linear motion, then you will use the inverse kinematics or X, Y, and Z of the robot to move to the position. And the third one is the path statement. This one allows us to automatically generate a movement from a fixture in our model. So if we import a 3D file, we can automatically generate a path around a corner. We'll come back to this a bit later. And in this example, we're going to weld together two metal plates, as you can see in the video. The idea is that the robot starts with the table straight and the robot straight, and then moves down to the middle point of the two plates and then welds a line. The video is now showcasing when points are being added to where the robot is going to move. So we just drag the robot around with the rotary table to get the positions we want and then add them as either a point-to-point movement or linear movement for this program. The points can also be dragged up and down depending on what order you want the robot to first hit before going to the next point. Afterwards, when the programming is done, you can run a simulation and see the movement of the robot. You can also turn the camera for different angles while the simulation is running to make sure that everything is okay and that there is no collision with the rotary table and the robot arm. In the output field, you can also see the program being printed out. So these are the movements the robot will execute. And these movements can be transferred over to the physical robot. It is also possible to add more points. If you see that there is missing some points where you want the robot to go, you can add them afterwards and then rerun the simulation to again verify that everything is okay and that the movement is still good. To be able to transfer the program you have created to the physical robot, you can press on the Connectivity tab. Then you press on the Welding Pose. This will connect your simulation software to an OPC UA server. In this case, the physical robot needs to be connected to the OPC UA server. And each time you run a simulation, the program you are running in Visual Component will be transferred over to the OPC UA server. You can then afterwards execute the same program you have created in the simulation software on your physical robot. In this case, we have taken the program we created in Visual Components and then transferred it to OPC UA server and are now executing it on the physical robot. We are here welding together the two plates as we did in the simulation, but in this case on the physical robot. For the second example, we are going to use the path function to automatically generate a robot movement based on a CAD file. The first thing we do is import the CAD file you want to use to create the path. This is done by pressing the geometry button in Visual Components. Afterwards, the part has to be attached to the rotary table to make the rotary table and the CAD file as one part. This is done by pressing the attach button and then pressing on the rotary table. This allows you to move the CAD file and rotary table as one unit. Then you add the same points as you did before for the point-to-point and linear movements to move to the part. Afterwards, you choose the path function in Visual Components. You then press on the curve you want the robot to move alongside. You also need to choose the right direction you want the robot arm to move in. And you also have to choose if you want the robot to move in the same axis as the coordinate system you have chosen for the path. Since we have a TIG welding robot, we have to move in the path of the feeder. However, if we would have a MIG welding robot, then the orientation wouldn't play a role. We can then see a path has been generated based on the curve of the part. However, we can see that half of the points are green while the rest are red. If the points are red, it means that the robot arm can't reach these points. To fix this, we first choose the last point where the robot arm will move for this curve. Afterwards, we rotate the table to a position where the robot arm can actually reach this position, and we then take the point of the robot arm and drag it over to the last point. Then we right-click on the last point and press Touch Up. This will smooth out the last movement. We will afterwards press on the path movement, as you can see here, and then press on the smooth button and then press on external axis. So here we're going to use the external axis to smooth out the movement of the robot arm so that it can reach all the positions in the half circle. In this case, the external axis are the two axes from the rotary table. And now when the simulation is running, you can see that it is rotating the table as it is moving. This allows the robot arm to have the right direction while it is moving, but also being able to reach all the points. As you can see in the sample, the robot stops and then moves to each point. If you want a continuous motion, you can choose all of the points and then press on the continuous or is continuous on the right hand side, which will then enable the robot and simulate it going in a continuous motion for the half circle. After, when the simulation is done, this same program can be transferred directly over to the OPC UA server and then executed on the physical robot, as can be seen here. In this video, we have showcased how to program in a linear movement or welding a linear line with our welding robot using visual components. We have also showcased how the system works. And at last, we showcased how we can automatically generate a path from a CAD file. This allows us for a flexible and fast method to reprogram a robot arm for welding. If you are interested in more tutorials on this module or other use cases, please follow the links in the description. Thank you for watching this Trinity module demonstration video.